Okay, so 6.2 is about the normal distribution. So normal distribution is a bell curve, shaped like a bell curve, and most of your data is in the middle, and then more students fluctuate on the outside. So this is what normal distribution looks like. 50% of your data is on this side, 50% is on this one. Your mean or your median, your mode is always right in the middle, the highest point of your bell shape. And your total, and so 100% of your data should be all underneath the curve. All right, so then you have certain standard deviation. That's just how far away you are from your mean. If you're one standard deviation, you're 68%. Don't look at the 0.26, just do 68%. If you're two standard deviations, you're 95%. If you're three standard deviations, you're 99.7%. These are your properties of a normal distribution. It's bell shaped. The highest point is your mean. Your mean, median, mode are all the same. The curve is symmetric. Total area of the curve is 1, which also means 100%. Roughly 68% is within 1 standard deviation, 95 is within 2, and the 99.7 is within 3. So let's look at this first example. Suppose that a distribution of scores of 1,000 students, so your sample is 1,000 students, it's a normal distribution, so it tells you it's bell-shaped. Your mean is 450, so x bar equals 450, and your standard deviation is 25. Find how many scores do we expect to fall between 425 and 475. So let's draw our bell-shaped curve. Your mean is 450. So let's find out what would one standard deviation be. Well, 25 this way would be 475, and 25 this way would be 425. So the first question would be, how many scores do we expect to fall between this? So this is one standard deviation. So we said one standard deviation was 68%. So how many scores? Well, if there's 1,000 students and 68% of them fall between those scores, we multiply it by 6.68, change it to a decimal, and that would be 680 students. So 680 students fall between 425 and 475. How many scores do we expect to fall above 500? So if I knew another standard deviation, we're going to go 25 more this way. So 25 more would be what? 500, right? And 25 more this way would be 400. So that's two standard deviations. And then if we went 25 more, this would be 525, and then 375, and that would be 3 standard deviations. So we want to expect to fall above 500, so this much, right? Well, from 500 would be, from 425 to 500 would be 95%, right? So that leaves how much, and this is from here to here, would be 95%, okay? So that leaves this end and this end, and we only want this end. So you have how much left over if 95% fall between here. That means you have 100% minus 95 leaves 5%, right? And that's from here, right here, and right here. But we only want this end, so both of these are 5%, so that means if we only want this half, you do 5% divided by 2, which leaves 2.5%. fall above 500. So we change that to a decimal, 0.025, and multiply it by 1,000, and you end up with 25. So 25, okay? All right, so this is an example of how you would do that. If you guys have any more questions on these, email me. I'll be happy to do another little video on this if you're not understanding any of this. All right, so z-scores. So sometimes we have different distances, not just like one standard deviation or 2 or 3. So for example, wanting to know the weight of women between the ages of 18 and 25. or if you want to know between 1.3 and 2.5 standard deviations. So this is when we're going to use our z-score, which is on page 348, and the z-score represents the number of standard deviations a data value is from the mean, and it's not our standard 1, 2, or 3. So if you look on page 348, it gives you guys your z-scores. So you can actually find the value, the percentage, and it's always, your standard is always going to be 0. So like your mean is 0 and you're finding the percent between 1.3 and 0. So you just go on your z-score, you look for 1.3, and it's going to be 0.403. That means this is 0.403, which will be 40.3%. So the first one is 40.3%, okay? All right, if you're looking for between 1.5 and 2.1, well, from here to here is 1.5, and from here to here is 2.1. So if you want just this area, you would have to take the area of the z-score of 2.1 and the z-score of 1.5, and what you want is the leftover, so you would have to subtract them. So the z-score for 2.1 is 0.482. So this is 0.482. And this right here is 0.433. And then you subtract them, and you get 0.049, and we move our decimal 2 places, so that would be 4.9%. All right, and then if you have a negative, it's just the opposite direction. So you have your curve, and then negative is this way, but it's still the same thing as what the positive would be, right? So you're still going to look up the positive number, and so this would be 0.466. Move it 2 places to the right, and this will be 46.6%. Okay, so try some more examples of those. There's several in the book, and you can try the ones in the homework and then look up your answers. And if you have any questions, please email me. All right, so then you also have raw z-scores, and to determine what that is, like if they give you actual numbers, okay, the weight is 20, standard deviation is 3, find the z-score of 25 pounds and 16 pounds, you would use this formula, x minus the mean, all divided by your standard deviation. So on this one, you would do 25 minus 20, which is your mean, all divided by 3. And you get 5 over 3, which is 1.67. And then, of course, this is your z-score, and you would just look this up on your chart, and you get about 0.453, which is about 45.3%. So about any dog or that weight is 25 falls about within 45.3% of the mean. Okay, and then you do 16 minus 20 over 3. That's negative 4 over 3, which is negative 1.33. Then you look that one up. It's about 0.408, so it's about 40.8%. Okay, so that means 16-pound dogs fall within about 40.8% within the mean. All right, so interpreting the significance of an exam score. So what if you want to score within the top 10% on your law exam to be eligible for a job, and you know the distribution is normal, and you made a 72 on the test, and the mean was 65, and standard deviation was 4. What percent of those who took the test was below yours? So the first question is, you want to know if you score within the top 10%. So we need to figure out the z-score. So how far away are you from the mean? So we know that you made a 72, so that's the x value. The mean was 65, so you're still doing your x minus x bar over s, and divide it by 4. So 72 minus 65 is 7 over 4, which is 1.75. So you think about it like this. Here's your 1.75, right? So this percentage, if you look it up, is 0.460. All right, but you want to know, okay, what percentage is this left over? Okay, well, this is 50%, right? So that's 0.50. So 50 plus 46% gives you 96%. So how many people scored better than you? Well, if you scored better than 96%, that means only 4% scored better than you. So did you score within the top 10%? Yes, you did. And then what percent of those who took this test was below yours? Well, 96% were below yours. So you did really, really well on this test. Okay, and then these are just some more z-scores. You would just do the same thing as what I just did with the x minus x bar on this one divided by s, and you could figure out which one was better based off that. And then here's some practice problems. All of these are odd, so you can look your answers in the back of the book, and if you guys have any questions, please contact me.